Good morning. Welcome to the Wolfram Technology Conference. My name is Lou D'Andrea, and this morning Peter Falloon and I will be taking a first look at some new technology we've been working on, Wolfram Alpha notebooks. I'm here to represent the notebook side, and I think it's safe to say that Peter's here to represent the Wolfram Alpha side. And you've all done your due diligence and read the abstract, so I won't go through this. You saw Stephen demo it yesterday as part of his talk, so I won't go too much into that. But I would like to give you a basis. All right, now we're on. I would like to give you a basis of where we have been in the past for Wolfram Alpha notebooks, for Wolfram Alpha support, and where we're going. So let's take a look at, so we have these two wonderful technologies. We've had Mathematica now for 30-odd years. We've had Wolfram Alpha for, what, 5, 7, 10 years, something like that. And there have been ways to communicate back and forth between them. So one of the things we did when we first developed Wolfram Alpha is we built this nice REST API. As a web service, you can access this REST API. Wolfram Mathematica accessed this web API. Initially, we built out a way to get full Wolfram Alpha results, exactly, mimicking the website experience in Mathematica. So you could type the equal sign twice to get into this mode where you get full results. And you evaluate this. I don't think this is going to be a surprise to anybody. You get sort of a full assemblage of what you might see on the website. The one difference, well, one of the interesting differences is that the contents of this sandwich of pods in Mathematica, well, on the web it's just a bunch of GIFs, right? And some links to other things. In Mathematica, these are native cells. So for an example as simple as this, perhaps that's not so useful, but for more complex examples where you might have images being returned, 3D graphics being returned, or other interesting cells being returned like manipulates. So here's an example where we have a 3D plot on the web. This just sits there doing nothing. In Mathematica, you can move this around. And here's an example where the actual web results could contain manipulates. And they don't contain manipulates directly on the web yet. But when delivering these things to Mathematica, they certainly can and do. And this is all well and good. The getting a multi-headed thing back as a result isn't all that useful. Getting this sort of monolithic thing back. What you might want is just a single piece of Wolfram language code, or a single subpod, if you like. So we built out a way to do that too. When you press equal only once, you get into this mode where you get not this full collection of pods, you just get a single thing. This turned out to be incredibly useful, and it's one of the key things that we're basing the Wolfram Notebook concept on. We also have this kind of inline syntax helper where you hold on the control key and you press equal, and you get a mode where a bit of language can be translated directly to, a bit of natural language can be translated directly to a bit of Wolfram language. So here we have, because there are plenty of places in the product, as syntax grows and grows and grows, our memories unfortunately don't. So I can't possibly keep in mind all of the entity syntaxes or the quantity syntaxes or all of these things. So it's convenient to have very nearby a product that can do that remembering for me and just look up, you type the natural language and then you get the Wolfram language thing out of it and it automatically goes and does the right thing. Okay, so that's kind of where we were in version 8 when Wolfram Alpha was first released. All of the previous technologies that you've just seen are based on the Wolfram Alpha function, which is sort of the API connector. It's the thing that actually goes off to the web service and grabs pieces of the pod content. Right, so that was the direction of using Wolfram Alpha from Mathematica. We also have a way currently on wolframalpha.com to lead users into the Mathematica infrastructure. People who otherwise wouldn't know about Mathematica, they go to the web, they see some query results, and when we get this pod content, if you hover over one of the pods, you get a sequence of controls. These controls many of the controls are leading people back into the Wolfram ecosystem. So the data button gives you, I think that might only be available for Wolfram Alpha Pro users, but it gives you choices to grab notebook content, other formatted content, data behind a particular result. The plain text link often gives you the Wolfram language, the Wolfram language translation corresponding to this particular pod. Interactivity gives you a pre-generated sort of canned notebook of content that might contain manipulates or other things downloaded that you can download to your machine. And the open code button over on the side here gives you a direct version of a notebook that you can open instantly in cloud. And this takes you to cloud and opens a notebook for you with your query sort of pre-populated. But all of these things are we are guessing what you want based on the one query and the one piece of information we have. So what is Wolfram Alpha Notebooks? Wolfram Alpha Notebooks is our attempt to give you the power of the notebook interface, but the simplicity of just typing queries by default. Let me demonstrate what I'm talking about. So we have the concept here is that Wolfram Alpha Notebooks, we want something where when you just type, currently in notebooks, when you just type, you get inputs. You get Wolfram language inputs. In a Wolfram Alpha notebook, you just type, you get a Wolfram Alpha query. What happens when you evaluate that query? Well, that goes off in sort of the single equal mode and tries to get a single Wolfram language expression corresponding to that query, and then evaluate that expression in your notebook. But it does have all of the power of the Wolfram Alpha infrastructures, such as assumptions, so that you can choose, how to disambiguate your query. Assumptions is also the way the API delivers formulas. So all of the wolframalpha.com queries that bring up formulas are going to work in Wolfram Alpha notebooks. One other interesting thing that we've been working on are the ability to provide input suggestions in addition to output suggestions. So let me demonstrate what that is for people who may not know. They're turned off here. So let me switch over to a different version of Mathematica. So here we have, let's see, how do I do this? No, okay. Well, I won't try that then. So we have always had the ability to produce predictions based on the Wolfram language, on your Wolfram language session. So you type an input, you get an output, and then you get this stripe that some of you may have turned off because this annoying stripe, I know what I want to do. I'm an experienced Wolfram language programmer. I don't need you telling me what I can and can't do. That's fine for experienced Wolfram language programmers, but for people who are new to the Wolfram ecosystem, maybe not even Wolfram language knowledgeable at all, it's a very useful thing. And we've developed an interesting extension of this. So let's do a sample query. By the way, this is a Wolfram Alpha notebook. As you've already seen, just typing into this notebook produces this orange framed cell. This is a Wolfram query cell, a natural language input cell. And evaluating this cell is going to go off to the server. So if we have good Wi-Fi here, it's going to go off to the server and grab a couple of things. So I want to point out a couple of things here before I turn over the rest of this talk to Peter. I want to point out that, so we have the query. We have the first thing under the query, as I mentioned, we have access to all of the Wolfram Alpha disambiguation features. So all the assumptions that you would see on the website for this query are here. The next stripe are input predictions. So input predictions are the things that, I guess on the web these would be called related queries, but these are things that can happen entirely in your own client session. So we have, I don't know, a handful of these guys. Say plot, function, and integral. That sounds interesting. So this goes off and takes a look at the query that you ran and the result that it provided, and then reruns a new query with the corresponding Wolfram language inputs and goes off and creates more predictions for them and gives you the result. Note that you're building up a session here in your Wolfram Alpha notebook without needing to type a single line of Wolfram language code. All you needed to do was start typing in the notebook. And of course, there's lots of interesting things that we could present as outputs for various queries. And that's one of the things that I think Peter is now going to show the sort of range of things that can be done and some of the more interesting features that we've envisioned for the Wolfram Alpha Notebooks project. Peter?
So I've got a notebook here with a bunch of examples kind of ready to go to illustrate a few things. I think Lou's actually covered some of them, so I might be doing a little bit of skipping. So firstly, interactive results. I think John mentioned in his talk earlier that the CDF plugin for browsers is not available for some time now. And that's a pity because a lot of inputs that have been supported for a long time in Wolfram Alpha actually cater for results that are interactive. So something like this. Pardon me? Yeah, cool. Is that enough? All right, cool. So yeah, so results like this, like a plot with a parameter in the argument of the plot that you want to vary, sort of brings up a manipulate expression. And then this, in a Wolfram Alpha notebook, this is just a regular manipulate object that you can play around with. And as Lou said as well, there's a lot of Wolfram Alpha results where the result itself is not interactive. It's, in this case, just an integral of something that gives a number. But if you look at the full Wolfram Alpha output, and you can see that spiky that I just clicked on is just the equivalent of double equals in a regular notebook. And some of the other pods in the result can be interactive. So here's a Riemann sum for the integral. So it's a bunch of rectangles that approximate the integral, and you can vary this. You can change the midpoint, and so on. So all of this interactivity kind of comes back to life when you're working in a Wolfram Alpha notebook. The next thing is getting other inputs. So I think Lou mentioned too that the thing of often with an input in Wolfram Alpha, some part of the input is ambiguous in some way. So Paris is usually Paris, France, but can also be Paris, Texas, or even Paris, Illinois, if anyone might be from there here. Slightly smaller city. But yeah, so that's available. And it's interesting that that isn't available when you do single equals in a regular notebook. So this is kind of a useful feature to have here. Input suggestions. Again, Lou mentioned this, so I'll just very quickly show this. When you do some kind of input, in this case, it's going to be an integral. There's a sort of a heuristic that runs, that looks at the integrate and sees that it's, it's an integrate of a symbolic expression. So it suggests a bunch of things that are likely to be of interest. So, you can plot a function and so on. And finally, also, the example pages that are on the web can be accessed from the Wolfram Alpha notebook here. So a query like plot example page. And what it does is it brings up a new Wolfram Alpha notebook with all those examples that would be normally seen on the web that you can scroll through and find and evaluate at your leisure. So okay, so yeah, one of the more popular features on the website is Stepbystep Solutions, particularly for homework and such things. So these are available here. Again, there's a heuristic that looks, I think it's looking at the input here to decide that this is something that's likely to have step-by-step solutions. So you click on this, it generates a new input and gives you the step-by-step solutions from Wolfram Alpha, as usual. Okay, so formulas and calculators. So formulas, as again Lou mentioned, they are available in Wolfram Alpha, and when you run a query for a formula where you haven't specified any numerical values, you just get this interface here to let you specify, so I can vary whatever I wanted to evaluate. click on equals, and it will go back to Wolfram alpha and give you the result with those parameters substituted. And the result is, the object that's returned here is a formula data expression. And just also, I wouldn't evaluate these, but just so you can quickly see that if you actually knew in advance the parameters you wanted to substitute, you could have included them in your query, and you wouldn't get the interface for that. If you don't know the formula at all, you can just enter a bunch of quantities, and the formula parser actually goes through and looks at whatever formulas actually fit with those quantities and returns everything it does. So here there's Ohm's law, there's also the power voltage current relationship, and you just get a list of the results. And so similar to formulas are calculators. So the idea with a calculator is whenever you know what you want to do, but you don't know what exactly to do it with. So, integrals, derivatives, limits, all these kind of things have these kind of calculator interfaces. And so these are all available in the notebook as well. Similarly for plots. So if you wanted to plot something, you don't know exactly what. And you can see that you get various optional fields that you can substitute. So here I've got a plot, and I can vary the range and the variable and so on. So this kind of as a workflow is kind of, particularly for like a classroom type environment where, the topic of the day might be differentiation or whatever. You can just bring up one of these and then just evaluate away to sort of see how things work. So just quickly, the two features that we're still kind of working on that are going to be key to this notebook sort of workflow are the ability to define variables in natural language. So it's all very well if you know exactly what you want to do, you can do it all in one line, but usually the way things are done in the notebook is you define a bunch of intermediate things. So here, I'm just going to define in a very kind of contrived example, just building up to expanding a polynomial here. So not too surprising, but the ability to define things like this will be quite useful. And also the ability to clear and remove symbols is also being added. So I'll just get out of that dev mode. Similarly, output references. So everyone who uses Wolfram language knows out minus n or percentage n as the way of referring to your previous results. We've made that work here as well, but for people who don't know about that syntax, we've also got sort of more natural language support. So if you somehow get a function and then decide you want to differentiate that function, something like differentiate this will evaluate and give you the percentage there. Integrate the above, to get back to where you started, will work in the same way. So we've got a bunch of these kind of natural language linguistics for sort of, hinting to the Wolfram alpha parser that you want to refer to a previous result. And similarly, graphics work, the same kind of things work for graphics, and this is quite useful if you want to plot something and then you want to adjust various aspects of the plot. So in this case, just adding a background. So make the background light gray and the above, it knows that the above means the previous plot and so on. And so the same kind of things can be done for images, but I think we're close to time, so I'll just skip the image example. And just finally, I'm not sure I think Stephen might have done this in his talk, but the fact that you have Wolfram language here in the output, for people who actually are curious or who are getting to know the language, they can actually start to edit this. So this is just a silly example where, I wanted to do some kind of manipulate, but the default ranges that were chosen in the manipulate weren't very useful. So I can adjust those. I can adjust the limit of the variable. So let's see. Right, so what this is, this example is just trying to show you the interference of sine waves with slightly different frequencies. And so that you get this kind of phenomenon. But, obviously this would have been quite annoying to have to go back and keep, modifying and making the input string longer and longer. So it's useful to be able to edit that Wolfram language code. Okay, so that's the end of my examples. I'm just going to quickly go back to the notebook and just summarize. So Wolfram alpha notebooks, who are they for? I think as we've hinted so far, it's for people who are familiar with Wolfram Alpha, but not very familiar with the Wolfram language. And it's giving those users a much more rich environment in which to work. So all the benefits of working in a notebook and with the formatting and so on. And as I also said, I think it's a useful stepping stone to the Wolfram language because you get the output in Wolfram language form. It's sort of, curious users are going to start to play around with that and get to see how it works. And we think this will be useful for classroom type environments where, like high school students who have never done any programming potentially or very little will be able to start doing real calculations in natural language. So in terms of availability, it's going to be a document type in Mathematica and also in the Wolfram Cloud, and also a standalone product, again geared at sort of classroom type markets. So finally, if anyone's interested and has ideas and suggestions, we'd love to hear. It's still very much under development. So I think with that, I'll finish. Thanks.